Welcome to today's deep dive. And right off the bat, I want you to check a calendar right now
Yeah, genuinely. Take a look at the date today.
because today is Sunday, March 8th, 2026. And the reason I really need you to anchor yourself in this exact present date is because the things we are about to discuss, they're not theoretical.
Where they aren't science fiction anymore.
Exactly. They are unfolding in the sky above you as you listen to this. We are looking at a story today that connects, of all things, a childhood powdered drink mix, the oldest weapon in human history, the quiet expiration of global arms treaties, and
And incredibly, the terraforming of the planet Venus.
it's a lot. It is a story of absolute awe, and it is a story of incredible urgency.
To guide us through this today, we're going to be drawing on two, well, incredibly dense, interconnected essays. And they were written this very year, 2026, by Zachary David Enfield.
Two fascinating texts.
Yeah. The first piece is titled Rods from God, Kinetic Bombardment, the Death of Arms Control, and the Architecture of the Unconstrained Sky. And the second one is called Centennial Collapse, a cascade engineering model for Venus terraforming.
Which sound like two completely different subjects.
They do, but they represent a unified theory of how humanity manages, or maybe fails to manage, ultimate power.
And that brings us to the mission for this deep dive. For you, the listener, our goal today is to unpack the ultimate dual-use technology. We're looking at a fundamental physics concept that can either drill through the deepest, most heavily fortified military bunkers on Earth, or...
Or breathe literal life into dead planets.
Right. And the chilling part, the part that keeps me up at night, is that the hardware is identical.
The physics is exactly identical.
The only variable that changes the outcome from apocalypse to Genesis is the intent of whoever happens to control the orbit.
Now, before we really begin, it is absolutely crucial that we explicitly state our strict neutrality on the subject matter we're going to be covering today.
Yes, very important point.
Because Enfield's essays delve deeply into highly charged, very active geopolitical events. Specifically, the text heavily references the recent United States and Israeli military strikes on Iran that occurred just over a week ago, on February 28th, 2026.
Just days ago.
Right. It also discusses the expiration of the New START nuclear treaty, and it analyzes the diplomatic and military reactions of nations, including Russia and China. As we navigate this material, we will impartially report the author's analysis.
Exactly. We are not taking any sides here.
We are not endorsing any state's military or diplomatic actions, and we are certainly not validating any specific political viewpoint. Our goal today is purely to convey the information, the physics, and the geopolitical framework contained in the source text.
Okay, let's unpack this. We are going to start in a place that feels, well, completely disconnected from orbital mechanics or global warfare. We are starting in the quiet, flat plains of Hastings, Nebraska.
Right in the middle of the country.
Yeah, I want you to picture the late 1920s. In 1927, there was an inventor named Edwin Perkins, and he was working in his kitchen on West First Street. He had this liquid concentrate he was trying to sell.
But shipping heavy glass bottles of liquid across the country was incredibly expensive and obviously prone to breakage.
Exactly. So he figured out how to dehydrate that sweet liquid into a tiny, very lightweight powder, and he called it Kool-Aid, with the original spelling ADE.
Right, the iconic drink.
It was sweet, it was simple, and it was a massive commercial success. But beneath that sugary drink mix was a profound, almost genius logistical philosophy. You take an enormous amount of potential, you concentrate it into the simplest, most deliverable form possible, you put it somewhere, and you just let chemistry do the rest.
And what is genuinely fascinating here is how the United States military independently arrived at that exact same philosophical conclusion on the exact same piece of land just 15 years later.
It's wild how that lines up.
It really is.
Yeah.
During the Second World War, the U.S. Navy needed a place to manufacture and store an absolute incomprehensible amount of explosive power. So they built a naval ammunition depot right there, southeast of Hastings.
Right on the prairie.
They took 49,000 acres of flat prairie grass and turned it into the single largest inland ammunition depot in the entire country. At its peak, this single facility produced and stored over 40% of the entire U.S. Navy's munitions.
40%.
Yeah, we are talking about 2,000 buildings, including hundreds of concrete, igloo-style storage magazines, completely hidden under mounds of earth and prairie grass. And it was all serviced by over 200 miles of private railroad track operating around the clock.
And the reason they put it there is what Enfield calls the logic of the prairie. Hastings was chosen because it was equally distant from both coasts, which made it safe from naval bombardment, but most importantly because no one was looking.
The sheer invisibility of the American Midwest was the primary defense strategy.
You just bury it in the vastness. In fact, to give you an idea of how much power was just sitting under that grass, in September of 1944, a catastrophic explosion happened at the depot. 9 men died. It left a crater 500 feet wide.
A massive accident.
The blast was felt 100 miles away, and yet the depot just kept operating. The thunder just went back to sleep under the grass. It was a localized apocalypse that the rest of the country barely even noticed.
And if we connect this to the bigger picture, the author argues that the low Earth orbit of 2026 is simply the modern equivalent of the Nebraska prairie.
The ultimate high ground.
Precisely. It is a place to hide concentrated destructive power in plain sight, trusting the vastness, the distance, and the absolute silence of space to keep the secret. And that brings us to the weapon itself, the rods from God. The formal military terminology is hypervelocity rod bundles, initially conceptualized as Project Thor.
I really want to dig into Project Thor because the history here is just wild. This was pitched back in the 1950s by a scientist and science fiction author named Jerry Pournelle.
A brilliant guy.
He went to the Pentagon with an idea that was elegantly terrifying. The Cold War was ramping up, everyone was terrified of nuclear winter, and he essentially said, what if we stop using nuclear weapons with all their radioactive fallout and political baggage and just drop a really big rock from space?
Though the design they eventually settled on wasn't a rock, of course. It was a cylinder made of solid tungsten.
Right. For those listening, try to visualize a standard wooden telephone pole, 20 feet long, 1 foot in diameter. Now imagine that entire shape made of solid, impossibly heavy metal weighing 24,000 pounds.
And the choice of tungsten is paramount to the physics of this weapon. Tungsten is incredibly dense. It's about 1.7 times denser than lead, but its true value lies in its thermal resistance.
Because re-entry is brutal.
Exactly.
Yeah.
It has a melting point of over 6,100 degrees Fahrenheit. When an object re-enters the Earth's atmosphere at hypersonic speeds, the aerodynamic heating is immense. The friction of the air molecules creates a literal plasma sheath around the object.
So a normal metal wouldn't survive.
Not at all. If you dropped a steel telephone pole, it would just melt. If you dropped titanium, it would ablate and burn away into nothing before it ever reached the ground. But tungsten endures. It arrives at the surface of the Earth in essentially the exact same condition it left the orbital platform.
I am stuck on the math of what happens when that actually hits. Kinetic energy equals 1/2 times mass times velocity squared.
Right, KE equals 1/2 mv squared.
It's literally first-year textbook physics. You take this 24,000-pound mass, you let it go from low Earth orbit, and gravity accelerates it to Mach 10. That's 10 times the speed of sound.
At that speed, the impact delivers the kinetic energy equivalent of 11.5 tons of TNT.
But unlike a traditional bomb, there is no chemical explosion. It is entirely clean. There is no radiation. There is no fallout. It's just pure, undeniable gravity and density, transferring all of that stored energy into the ground in a fraction of a millisecond.
Which naturally raises an important question that any strategic planner would ask. If this concept is so theoretically perfect, and the physics were clearly understood back in the 1950s, why haven't these weapons been deployed?
Right. Why aren't they hanging over our heads right now?
The answer is not that the engineering was impossible. The answer is entirely economic. The barrier to entry was the cost of gravity itself.
Right, because getting heavy things into space used to be financially ruinous. During the space shuttle era, it cost about $54,000 to put a single kilogram into low Earth orbit.
An astronomical price.
So at that price, launching just one of these 12,000-kilogram tungsten rods would cost over $640 million. And you wouldn't just launch one rod. A full orbital platform with a magazine of 6 rods, the satellite bus to control it, and the launcher mechanism, that would have cost $4 to $5 billion per satellite.
Even the Pentagon, with its massive budgets, looked at that price tag and realized it was completely unfeasible. It remained a science fiction fantasy simply because the delivery truck was too expensive.
But then, the economics of orbital launch completely collapsed.
And this is where Enfield introduces Musk's law and the commercial space revolution. First, you had the SpaceX Falcon 9 and Falcon Heavy, which brought the cost down to around $1,400 per kilogram by reusing the first stage boosters.
Which was already a massive drop.
Huge. But the real paradigm shift, the one that makes the source text so unbelievably urgent today, is happening right now with the Starship platform. With Starship's fully reusable heavy lift capabilities, launch costs are plummeting to between $78 and $94 per kilogram.
That's just wild.
Furthermore, projected highly reusable flights are mathematically driving that down to an astonishing $10 to $30 per kilogram.
Let's really do the math on that because the numbers are staggering when you apply them to weapons. We're looking at the current price tag for a fully functional Rods from God platform, the raw tungsten. It trades at about $50 a kilo on the industrial market.
Pretty cheap for what it is.
Exactly. That means all 6 rods cost roughly $3 million. The launch cost under the Starship pricing model. Maybe $6 million to get all that weight up there. The only truly expensive part is the satellite bus, the railgun launcher mechanism, and the nuclear battery, the radioisotope thermoelectric generator, which runs about $200 million.
So your total price tag for a fully operational permanent orbital kinetic strike platform is between $210 and $250 million.
To understand the geopolitical gravity of that number, the author points out that $250 million is exactly the cost of 2.5 F-35 Lightning II fighter jets.
And let's really consider the logistics of an F-35 compared to this. An F-35 costs around $83 million up front. But an F-35 is inherently fragile. It requires hundreds of hours of ground maintenance. It operates in a single, localized theater of war.
It can be grounded by bad weather.
Right, bad weather. Or its electronics can be jammed by electronic warfare. Its highly trained pilot can be killed. It can be shot down by surface-to-air missiles. In fact, defeating an F-35 is a global industry involving hundreds of billions of dollars in adversarial research and development.
And you compare that to a tungsten rod dropped from orbit. It has no pilot to train or lose. It has no jet fuel to ignite. It has no complex radar arrays or flight computers to jam.
It operates 24 hours a day, 7 days a week.
Loitering over every single theater on Earth simultaneously. And because there is no explosive launch plume, no rocket engine firing when it drops, you don't even know it's been released until it hits the thickest part of the atmosphere.
By the time ground-based radar detects a Mach 10 hunk of metal coming straight down, the target has roughly 11 seconds before impact.
11 seconds. You can't shoot it down. If you somehow manage to hit a Mach 10 tungsten rod with an interceptor missile, you don't destroy it, you just fracture it. You turn one giant kinetic bullet into a hypersonic shotgun blast that still completely obliterates the target area.
So you aren't just comparing the price of hardware here. You are comparing the cost of mass mortality. When a weapon of this magnitude becomes cheaper to build and deploy than a conventional fighter aircraft, it democratizes the apocalypse.
That is a terrifying phrase.
We are moving from a world where only superpowers with multi-trillion-dollar budgets could afford orbital weapons to a world where mid-sized corporate entities or private wealth could theoretically access them. The financial barrier that protected humanity from orbital bombardment has completely vanished.
But the sheer speed and weight are only half the story here, because the actual engineering of the rod goes so much deeper than just dropping a heavy rock from a high place. And this is the part of the source material that genuinely blew my mind.
The physics of the impact itself.
Yeah. If you just drop a perfectly symmetric, straight rod, it actually has a massive flaw. It acts exactly like a nail being driven into wood.
Right, if the rod is perfectly symmetric, the center of mass is perfectly aligned with the geometric centerline. As it impacts, the staggering kinetic energy liquefies the target material, be it bedrock or heavily reinforced concrete, and the rod pushes through.
But just like a nail, the displaced material closes back in around the shaft.
Exactly. The immense pressure creates friction along the sides of the rod. This shaft friction is the primary force that limits penetration. In ballistic physics, a symmetric penetrator is generally limited to a depth of about 5 to 7 times its own diameter before the friction bleeds off all its kinetic energy and brings it to a dead stop.
So for a 1-foot diameter rod, that means it might stop after penetrating just 7 feet of solid rock.
Which completely defeats the purpose if you were trying to hit a military bunker buried hundreds of feet underground.
Right. So the weapons engineers looked at this friction problem and came up with a tweak that is as brilliant as it is sinister. The offset nose weight.
They deliberately break the perfect symmetry of the rod.
They machine a slightly heavier mass off-center inside the nose cone, and when they launch it from the orbital platform, the electromagnetic railgun doesn't just push it out. It spins the rod at thousands of revolutions per minute, exactly like a rifle bullet leaving a barrel.
And this introduces a fascinating application of gyroscopic physics. Because the center of mass is slightly displaced from the spin axis, it creates a continuous torque couple. As the rod falls, it doesn't tumble end over end, but it experiences what physicists call gyroscopic precession.
Wait, let me make sure I'm visualizing this correctly for everyone. Are we talking about what happens to a spinning top when it starts to lose speed and the top of the toy starts tracing a wider circle in the air while the point stays perfectly on the table?
That is an excellent analogy,
Yeah.
yes. The nose of the rod traces a tight, incredibly fast circle as it falls, sweeping out an arc that is slightly wider than the rod's actual body. It transforms the weapon from a nail into a drill bit.
That is insane.
When it hits the ground, that precessing, spiraling nose cuts a bore, a channel, that is slightly wider than the shaft of the rod following behind it.
So as the rest of the rod plunges into the earth, the sides of the rod are literally not touching the walls of the hole it just created.
The shaft friction is completely eliminated.
If I can use another analogy, it's like trying to push a straight stick into wet sand. Eventually, the sand squeezes the sides of the stick so hard you can't push it any further. That's shaft friction. But if you wiggle the stick in a circle as you push, you're creating a hole wider than the stick itself, and it slides right in.
The offset weight is basically doing that circular wiggle, but at thousands of RPMs, through solid granite.
By eliminating that shaft friction, the penetration depth becomes almost strictly a function of the tip's pressure and velocity. It doesn't stop at 7 feet. It can theoretically penetrate hundreds of feet into solid bedrock.
Furthermore, this offset nose weight solves a massive tactical problem known in ballistics as oblique entry.
Right, hitting on a slant.
If a perfectly straight rod hits the slope side of a mountain, the angled impact can cause it to deflect, potentially missing the underground bunker entirely. But with the precessing circular cutting action of the nose, the lateral force is redistributed. It acts like the threads of a screw.
It doesn't bounce or deflect.
It actively threads itself into the angled surface, maintaining its downward trajectory with absolute precision.
This means literally no underground facility is safe. The author brings up Operation Midnight Hammer from June 2025, which, again, we are just impartially reporting from the text.
Right, sticking to the source material.
In that operation, the U.S. used its biggest conventional bunker buster, the 30,000-pound Massive Ordnance Penetrator, or MOP bomb, against the Fordo nuclear facility in Iran. That bomb, as massive as it is, can penetrate maybe 200 feet of rock.
But nations are well aware of that limit and are already building deeper. Iran is reportedly constructing facilities at 100 meters, or over 300 feet, deep.
The U.S. has the famous Cheyenne Mountain Complex. Russia has deep command centers under the Urals.
This offset-nose tungsten drill renders all of that rock, all of that concrete, and all of those billions of dollars in defense completely useless.
And that realization breaks the very foundation of global peace, because our entire geopolitical framework since the 1950s is built on nuclear deterrence.
The doctrine of mutually assured destruction relies fundamentally on two pillars: the survival of command authority and immediate attribution.
First, your leaders and your communication bunkers must survive a first strike so they can order a retaliatory second strike. That is what keeps anyone from pulling the trigger, the knowledge that they will be destroyed in return.
And second, you must know immediately who attacked you, so your surviving forces know who to shoot back at. The kinetic rod shatters both of these pillars simultaneously.
I want to look at the legal side of this because a rational person would assume putting something this devastating in space must be highly illegal.
You would think so.
In 1967, the world signed the Outer Space Treaty. It explicitly bans putting nuclear, biological, or chemical weapons of mass destruction into orbit. But legally speaking, a tungsten rod is just a piece of metal.
It's just mass.
It has no explosive yield. And the electromagnetic railgun that drops it. Legally, that's just a propulsion or deployment system. It's a loophole the size of the telephone pole.
It is a massive legal vacuum, and the strategic nightmare is compounded by that lack of attribution we just mentioned. If a ballistic missile is launched from a silo or a submarine, infrared early warning satellites detect the massive heat plume of the rocket engine instantly.
We see it right away.
The physics of launching a missile make it highly visible. We know within seconds exactly where it launched from and whose airspace it originated in. Retaliation protocols can be authorized by a head of state in minutes.
But a tungsten rod, there is no launch plume. The satellite simply opens a bay door and lets go of it. A small, cold gas retrograde burn nudges it out of orbit, a burn so incredibly small it is entirely lost in the background noise of the 12,000 other commercial and military satellites constantly maneuvering up there.
So by the time your ground-based radar picks up this supersonic piece of metal dropping through the atmosphere, you have 11 seconds until it hits your deepest command bunker.
You don't know who dropped it.
By the time the dust settles, you measure the crater, and you try to mathematically calculate the trajectory backward into space, the specific satellite that dropped it has already continued along its orbit, doing a lap around the Earth at 17,000 miles an hour.
It is the ultimate decapitation strike, and it doesn't trigger a single nuclear early warning system.
The timing of this capability becoming economically viable is deeply unsettling, and Enfield anchors this dread in a specific, very recent date, February 5, 2026.
Just last month.
On that day, the New START treaty between the United States and Russia officially expired. There is no successor agreement in place. For the first time in over half a century, there is no binding legal limit on the strategic nuclear arsenals of the world's two largest powers.
And the verification and inspection regimes have entirely dissolved. We are operating in a total legal and diplomatic vacuum at the exact historical moment that the cost of launching orbital mass has fallen by a factor of 5,000.
Which brings us to the geopolitical urgency of right now, March 2026. The source text outlines the immediate context, and we're going to walk through it.
On February 28, 2026, U.S. and Israeli strikes killed Iran's supreme leader. Iran responded with massive drone and missile barrages across the Middle East. China and Russia have publicly condemned the U.S. strikes. The doomsday clock has been moved to 89 seconds to midnight.
And again, to you listening, we are impartially reporting the geopolitical backdrop that the author uses to frame the urgency of this technology. We are not endorsing any side of this conflict or validating the military decisions described.
We are simply setting the stage for how close to the edge humanity is standing today.
The author uses this incredibly tense, fragile backdrop to introduce a theological framework to explain the psychological impact of this weapon. When humanity creates a weapon that transcends all legal boundaries and physical defenses, military strategy suddenly starts sounding like theology.
He quotes from the book of Revelation, chapter 6, verses 15 through 17, a passage known as the Wrath of the Lamb.
The text describes the kings of the earth, the generals, the rich, and the mighty, hiding in the caves and among the rocks of the mountains. They ask the mountains and the rocks to fall on them to hide them from the wrath.
Enfield argues this isn't just an abstract religious metaphor. In 2026, it is an accurate architectural description of how military power organizes its survival.
That's a haunting way to put it.
It really is. The kings and generals are literally hiding in the rocks, in Cheyenne Mountain, in Raven Rock, in deep bunkers under the Urals and the Zagros Mountains. And people expect a weapon from space to look like a Hollywood movie.
They expect a glowing red fireball streaking across the sky.
A roaring sound building up, a massive, fiery explosion. But as we discussed, tungsten doesn't melt. It doesn't ablate into a glowing plasma tail. It arrives in total, terrifying silence because it is moving so much faster than the speed of sound. The noise of its arrival literally cannot catch up to the object itself.
The sequence of events for those inside the bunker is chilling. Nothing, and then the impact.
Just instant devastation.
The sound isn't an explosion, it is a compression of air and earth, so sudden and violent that it feels like a localized earthquake. Inside those deep bunkers, the lights go out, the reinforced granite cracks under the sheer kinetic shockwave, and the mountain itself is physically driven downward.
The kings and generals built the mountain to cover them, and the tungsten rod turns the mountain into their tomb.
And it perfectly explains why you wouldn't just sneak a nuclear warhead inside the tungsten rod to make sure the job gets done.
If you do that, you instantly violate the Outer Space Treaty. You add radioactive fallout, which is measurable and trackable. You trigger global nuclear tripwires that could end the world.
The pure kinetic rod is completely legal under current treaties. It's completely silent. And it's deadly enough to reach the deepest targets on Earth without a single ounce of explosive chemical.
It mimics the divine weapons of ancient myths, Zeus's thunderbolt or the Hindu Brahmastra. It's an unchallengeable vertical judgment.
Which leaves us standing on a very dark precipice. The legal framework of arms control is gone. The launch costs have collapsed, making orbit accessible to almost anyone. The physics of the gyroscopic drill bit are perfected.
The geopolitical world is on fire.
So what does this all mean? Are we doomed to simply build this apocalyptic stick, point it at our own planet, and wait for the caves to fall in on us?
I know, reading the first essay, I felt entirely hopeless. But here's where Enfield executes a stunning pivot. In his second essay, Centennial Collapse, he reveals that this exact same technology, the identical tungsten rod, the identical electromagnetic railgun, the identical orbital launch platform,
Is the key to creating life.
it's the ultimate twist.
He introduces a philosophical concept he calls the prior claim. His argument is that the terraforming of dead planets is what this immense physics was always meant for. The military application, the bunker-busting weapon hovering over foreign capitals, is simply the human failure mode of this technology.
We just have to shift our gaze away from Earth's conflicts and look outward, specifically to Venus.
Let's talk about Venus because it is the most hostile, hellish planet in our solar system. Surface temperature is 450 degrees Celsius, hot enough to melt lead.
The atmospheric pressure is 92 times that of Earth's sea level. Standing on the surface would feel like being crushed a mile underwater.
The atmosphere is 96.5% carbon dioxide with thick clouds of sulfuric acid. Traditional planetary science says that fixing Venus, if it's even possible at all, would take millennia.
But Enfield proposes a model called centennial collapse that takes exactly 1 century.
The underlying philosophy of the centennial collapse is a shift from additive brute force to what he terms a multiplicative cascade. Traditional models assume you have to manually remove the heavy atmosphere, which requires more energy than we could ever generate.
Enfield says you don't try to manually blow away the massive atmosphere. Instead, you treat Venus as a thermodynamically sensitive, highly complex system. It is currently in a stable, albeit deadly, equilibrium.
If you introduce highly coordinated, synchronized perturbations, like nudging a boulder at the top of a hill, you can tip it out of that equilibrium.
Once you push it past a certain critical threshold, the planet's own immense thermodynamic feedback loops take over and do 99.5% of the terraforming work for you.
I want you to imagine a cosmic orchestra tuning up. Enfield describes a symphony of 6 massive, integrated instruments that will play together to break the atmosphere of Venus.
The level of engineering detail he goes into here is incredible. Let's look at the first instrument, the orbital mirrors. This is the catalyst that starts the cascade.
The orbital mirrors establish the fundamental thermal gradient that drives everything else in the model. They deploy 40,000 massive, ultra-thin cooling mirrors at the L1 Lagrange point.
For context, the L1 point is the gravitational balance point between Venus and the Sun, where an object can basically hover in a stable position.
This massive mirror array blocks 30% of the sunlight, specifically targeting one pole of the planet, creating a deep, permanent cold trap. Simultaneously, they deploy an array of 10,000 magnifying parabolic mirrors in orbit to focus sunlight intensely onto the opposite pole, superheating it to over 2,000 degrees Celsius.
So you have one freezing pole and one boiling pole. This creates a 1,500-degree temperature difference across the entire planet. Now, because the atmosphere is so incredibly dense, remember 92 times Earth's pressure, that extreme temperature gradient drives massive continuous winds.
We're talking about winds blowing at 500 meters per second. It creates a permanent artificial planetary storm that aggressively mixes the stagnant atmosphere.
That's instrument 1, just setting the stage. Instrument 2 is where things get truly wild, and I need you to explain this because I struggled with it. Teraton-scale thermonuclear devices.
I understand the hesitation. Detonating nuclear weapons to save a planet sounds completely counterintuitive.
It sounds like blowing it up.
Exactly. This concept is actually based on the 1950s Project Sundial. Back then, scientists like Edward Teller realized that the Teller-Ulam staged fusion design, the basis for modern hydrogen bombs, has no theoretical yield limit.
Meaning you can just keep making them bigger.
Right. If you keep adding fusion stages using the energy of the previous stage to ignite the next, you can scale the explosion infinitely. A 3-stage device yields 10 gigatons. Enfield proposes a 5-stage device that yields 1 teraton.
That is 1,000 gigatons of explosive energy.
Okay, to put that in perspective for the listener, 1 teraton is roughly 1/10 the energy of the Chicxulub asteroid impact, the one that wiped out the dinosaurs.
How on earth does setting off a dinosaur killer nuke help terraform Venus? Doesn't that just blow the planet to pieces or irradiate it forever?
That is exactly the right question to ask. The key is where they detonate them. They aren't dropping these on the surface to blast the crust apart. They are detonating them in the middle of the atmosphere, 50 to 70 kilometers up.
Oh, because the air is so thick.
Because the atmosphere on Venus is as thick and heavy as an ocean, these blasts don't just dissipate into a vacuum. They create what the author calls scalable earthquakes in the air.
Earthquakes in the air.
The immense thermal and kinetic shock waves triggers massive convective upwellings. It physically punches temporary holes in the dense atmospheric layers, forcing the superheated carbon dioxide gas up toward the edge of space where it could be stripped away by solar winds.
As for the radiation, the intense artificially generated winds from the mirrors disperse the fallout so rapidly that it doesn't settle into toxic hotspots.
That is mind-bending. Okay, so instrument 3 is where our tungsten rods return. Kinetic bombardment. We take the exact same weapons platforms we were terrified of in SA-1, but here they are scaled down slightly to 4-ton penetrators.
A constellation of 20 orbital railguns fires 30,000 of these rods into the Venusian surface every single year.
They aren't aimed at bunkers, they are aimed at the virgin crust of the planet. They smash into the ground, excavating fresh calcium and magnesium silicates from deep underground.
And this is brilliant planetary chemistry. When that fresh, unweathered silicate rock is violently exposed to the extreme carbon dioxide atmosphere, it immediately reacts.
The heat of the impact accelerates a chemical reaction that pulls the CO2 directly out of the air and binds it, turning it into solid calcium carbonate rock.
The kinetic bombardment is literally a massive, violent carbon sequestration engine. It is physically beating the deadly atmosphere into solid stone.
So we have winds, atmospheric earthquakes, and rods turning air into rock. Then we add Instrument 4, high-energy lasers.
The lasers operate from 50 orbital platforms firing free electron lasers continuously down into the atmosphere. You cannot conventionally burn carbon dioxide. It is already fully oxidized.
But these specific lasers operate at extremely precise wavelengths that cause photochemical dissociation. They pump so much targeted energy into the CO2 molecules that they literally vibrate apart, breaking down into carbon monoxide and oxygen radicals.
In the turbulent, well-mixed atmosphere created by the mirrors and the nuclear blasts, these newly freed radicals chain react into completely new chemical compounds that are much lighter and far easier to vent into space.
It's like tenderizing a tough piece of meat before you cook it. They are breaking the chemical bond so the other instruments can do their work.
Finally, we have Instrument 5, acoustic resonance. This sounds like pure science fiction to me, but Enfield insists it's just scaled-up physics. We are talking about giant orbital platforms trailing down into the upper atmosphere with 500-meter reciprocating pistons generating incredibly low-frequency sound waves.
These waves are so massive they wrap around the entire planet, bouncing back on themselves to create standing wave patterns.
Walk me through that, because what does an acoustic standing wave actually do on a planetary scale?
The author describes this instrument as shepherding the chaos. Think about what we've done so far. The nuclear blasts, the thermal gradients from the mirrors, and the laser heating create immense, chaotic kinetic energy in the atmosphere.
The acoustic standing waves serve to mathematically organize that chaos.
In a standing wave, there are nodes of high pressure and antinodes of low pressure. By carefully tuning these frequencies, the engineers create permanent low-pressure channels.
Essentially massive, invisible chimneys made of sound.
These acoustic chimneys guide the chaotic upwelling atmospheric mass directly to the high-altitude zones where it can most easily escape the planet's gravity.
I'm just picturing all these instruments playing together, the mirrors driving the wind, the nukes punching the holes, the rods exposing the rock, the lasers breaking the bonds, and the sound waves funneling the exhaust.
Enfield notes that by year 30 of this century-long plan, the cascade becomes completely self-sustaining. The planet is actively participating in its own transformation.
The artificial ice caps at the cold pole grow, reflecting more sunlight. The atmospheric pressure drops, allowing the temperature to plummet further. It is an absolute masterpiece of engineering.
But listening to this, stepping back into reality for a second, you really have to wonder, who on Earth pays for a 100-year planetary engineering project?
It is a massive undertaking, but the math is surprisingly grounded. The author calculates the total cost of the Venus terraforming project at roughly $1 trillion, amortized over the 100-year duration. That equates to $100 billion a year.
To put that in perspective, $100 billion is just 0.1% of current global GDP. It is roughly equivalent to NASA's current annual budget, or pointedly, what the United States currently spends each year just maintaining and modernizing its nuclear weapons arsenal.
The financial resources absolutely exist right now. As for the material resources, like the vast quantities of tungsten required, that would be sourced through asteroid mining, which is already in early commercial development.
It is not an issue of capacity, it is an issue of political and human will.
Enfield brings up a beautiful theological framing here to explain that will. He talks about the Hebrew word Yisrael. It translates to one who struggles with God.
It comes from the biblical story of Jacob, who finds himself alone by a river at night and ends up wrestling with an angel, or God, through the entire night.
It is a brutal fight. Jacob gets his hip dislocated. He is injured. But he refuses to let go until dawn, and because he holds on, because he doesn't give up the struggle, he receives the blessing and his new name.
It is a profound metaphor for humanity's relationship with ultimate power. Every generation discovers a new physics it doesn't fully understand. We discover nuclear fission or genetic engineering or artificial intelligence, or, in this case, the terrifying power of orbital kinetic energy.
We find ourselves at the river in the dark, wrestling with this immense power, terrified it will destroy us. If we let go, if we let the kings and the generals and the strategic military interests take sole control of the physics, we get the rods from God.
The mountain falls on us, and we are destroyed in our own caves.
But if we hold on through the night, if we endure the geopolitical terror and refuse to let the military-industrial complex claim the physics for destruction, the exact same technology, the identical hardware, gives us a terraformed solar system.
It gives us a living Venus.
The technology itself is completely neutral. A tungsten rod falling at Mach 10 does not know if it is aimed at a command bunker in Iran or a subsurface rock deposit on a dead planet. It's simply waiting for human intent to give it purpose.
The physics is just gravity, mass, and velocity. The hardware is just machined metal and circuitry. The outcome, whether it brings the apocalypse or Genesis, is determined entirely by the covenant we choose to make with the power we have uncovered.
What an incredible journey we've been on today. We started with Edwin Perkins mixing Kool-Aid on a quiet street in Hastings, Nebraska, learning how to concentrate power and hide it in plain sight.
We followed that logic up into the unconstrained sky of low Earth orbit, calculating the terrifying math of hypersonic tungsten drill bits.
We stared down the geopolitical cliff edge of March 2026, with expiring treaties and silent, unchallengeable weapons hovering above us. And then we looked outward, taking that exact same apocalyptic stick and using it as a conductor's baton to orchestrate the resurrection of an entire planet.
It is a sweeping, inspiring vision, but there is one final chilling extrapolation we need to consider before we finish, drawing from the authors section on the non-state actor horizon.
We discussed earlier how the launch costs and materials have plummeted so drastically that a fully armed orbital platform now costs roughly the same as a mid-sized corporate acquisition.
What happens when a private, multinational mining conglomerate puts a kinetic bombardment platform into low Earth orbit?
Wait, how could a corporation possibly justify putting a weapon of mass destruction in orbit?
Under the current, glaring legal vacuum of the Outer Space Treaty, they wouldn't call it a weapon. They could claim the platform is simply a seismic probe designed for asteroid mining or early-stage planetary engineering.
Which, as we've spent the last hour discussing, is a perfectly valid, scientifically backed application of the exact same dual-use hardware.
They're completely within their legal rights to park that platform above the Earth. It is completely invisible to regulatory oversight right up until the exact moment they decide to drop a tungsten rod on the headquarters of a corporate rival or hold a sovereign nation-state hostage over resource rights.
The line between a visionary terraforming tool and an unstoppable apocalypse weapon isn't just invisible to governments anymore. Within a decade, it might be entirely in the hands of CEOs.
That is a deeply unsettling thought to leave you with. The democratization of apocalypse, legally masquerading as commercial enterprise.
Thank you so much for joining us on this deep dive. We've given you a massive amount of information to process today, from the quiet plains of Nebraska to the raging artificial storms of Venus. Keep asking questions, keep looking up at the sky, and keep wrestling with the big ideas. We'll see you next time.
Okay, so imagine a weapon. It can strike anywhere on Earth, right from space. It hits with the force of a small nuke, but there's no fallout and you get almost zero warning. And get this, it's not science fiction anymore. They call it rods from God, and it's all about owning the ultimate military high ground, which is, of course, orbit. You know, we've all heard that famous Einstein quote, right? World War IV will be fought with sticks and stones. It always sounded like a metaphor, didn't it? A warning about total collapse. But what if? What if he was being literal? What if the most powerful weapon we could create isn't some complex bomb, but something as basic as a rock or a stick, just dropped from orbit? But here's the twist. The story of this crazy, futuristic weapon, well, it doesn't start in some top-secret lab or a skunkworks facility. Nope. It starts right here, in a small town on the American prairie. I'm not kidding. Hastings, Nebraska. Of all places, a town that, without even trying, kind of laid out the blueprint for concentrating and delivering just overwhelming power. Okay, stick with me here because this parallel is wild. Back in 1927, an inventor in Hastings figures out how to concentrate all this flavor into Kool-Aid powder. Simple, right? Well, 15 years later, the U.S. Navy looks at that same wide-open prairie and decides it's the perfect place to hide 40% of its entire munitions supply. Think about it. The strategy is exactly the same. You concentrate massive potential, you keep it hidden, and you get it ready for rapid delivery. So this gives us what we're going to call the prairie principle. It's a really simple three-step logic. 1. Concentrate enormous potential. 2. Store it invisibly. And 3. Release it with overwhelming effect. Remember that, because this simple idea, it's the key to understanding everything we're about to talk about. All right, so now let's talk about the weapon itself and see how this all connects. We're taking that prairie principle and we're scaling it way up. We're not talking about drink mix or ammo dumps anymore. We're applying it to a massive, solid metal rod, just hanging out in space. The official term for this is kinetic bombardment. And really, it's the oldest weapon in human history, just taken to an insane extreme. There are no explosives here, no warhead. It's literally just a very, very heavy object, dropped from an incredible height, letting gravity do all the dirty work. So first let's talk mass. The rod itself is made of solid tungsten, one of the densest metals we have. And when we say rod, picture a telephone pole. Now imagine that telephone pole weighs 12 tons. Okay, so you have that incredible mass. Now let's add some speed. As this thing screams back into the atmosphere, it's hitting Mach 10. We're talking over 7,600 miles per hour. And that's exactly why they use tungsten, by the way. It has such a crazy high melting point that it can actually survive that fiery plunge back to Earth. So what happens when you combine that much mass with that much velocity? You get pure, raw kinetic energy. That 12-ton rod hits the ground with a force of almost 12 tons of TNT. All of that power focused on a single point. But wait, how does a big metal stick defeat a bunker buried hundreds of feet underground? Well, this is where it gets really clever. A standard symmetrical rod, it just acts like a nail. It punches through, sure, but friction from the dirt and rock slows it way down. But if you add a little offset weight to the nose cone, something amazing happens. The rod starts to spin as it falls. It stops acting like a nail and starts acting like a drill. It carves a channel that's actually wider than itself, which pretty much eliminates all that friction. This lets it penetrate to just unbelievable depths. It even self-corrects if it hits the target at an angle. Genius, right? Now, for decades, this whole idea was just pure science fiction, a cool fantasy. And for one simple reason, it was ridiculously expensive to get anything into space. But now, well, the economics have totally flipped, turning a Cold War pipe dream into a very real, very present-day calculation. Just look at these numbers. Back in the space shuttle days, it cost more than $54,000 to launch a single kilogram into orbit. Think about that. That means one of our tungsten rods would have cost over $500 million, and that's just for the bus ride to space. But today, with reusable rockets like SpaceX's Starship, that cost has absolutely collapsed. We're talking around $100 a kilogram. That is a 99.8% price drop. And it changed that big? It changes absolutely everything. Okay, let's put that new cost into perspective. For about the price of just 2 or 3 F-35 fighter jets, a country could deploy a weapon that is, for all intents and purposes, invulnerable. You can't shoot it down, you can't jam it, it's watching the entire globe 24/7. And the warning time, the time from when you see it coming to when it hits you, you've got about 11 seconds. Good luck. All of a sudden, the math isn't about dollars and cents anymore, is it? It's about a fundamental tectonic shift in strategic power. At this point, you are not comparing prices. You are comparing mortality. Okay, so you're probably thinking, surely a weapon this powerful has to be illegal, right? Well, that's where this whole story takes another complicated turn. It turns out, all those arms control treaties we've spent decades writing, they just weren't designed to handle a weapon like this. You have to understand, the whole legal framework that's kept the peace for half a century is pretty much unraveling before our eyes. The big one, the Outer Space Treaty, was signed way back in '67. But more recently, the New START Treaty, that was the last remaining nuclear arms deal between the US and Russia. It's effectively dead. And that means, for the first time since 1972, there are no limits on their nuclear arsenals. But the real key is in the precise wording of that original 1967 treaty. It's very specific. It bans nations from placing two things in orbit: nuclear weapons and any other kinds of weapons of mass destruction. And there it is. That's the loophole. A kinetic weapon isn't legally either of those things. Think about it. It has no nuclear material, no explosives, no chemical or biological agents. As far as international law is concerned, it's just a big hunk of metal. A hunk of metal that slips perfectly through a legal loophole, the exact size of a telephone pole. The consequences of this are, well, they're staggering. All of a sudden, you have a quote-unquote clean weapon that makes a decapitation strike, taking out a country's entire leadership, actually seem plausible. This is a direct threat to the whole idea of mutually assured destruction, the very thing that's kept us from nuclear war for 70 years. And what's worse, since the weapon is just dropped from a satellite, figuring out who actually fired it is incredibly difficult. That creates an absolute nightmare for anyone trying to figure out how or who to retaliate against. So let's bring this all full circle. Let's go back to Einstein, back to those sticks and stones, and really dig into the final, profound choice this technology forces us to make. Because here's the most mind-bending part of this entire story. The exact same technology, this tungsten rod that can obliterate a bunker on Earth, could also be used to drill channels for clean geothermal energy. Or it could be used to map subsurface ice on Mars. One is a weapon of war, the other is a tool for terraforming. The hardware is identical. The only thing that changes is our intent. And that brings us right back to Einstein. He wasn't just being poetic, was he? It turns out he was more literal than he could have ever known. In our long search for the ultimate weapon, we've stripped away all the complicated parts, the explosives, the guidance systems, the electronics, and we've come back to the simplest, most brutal equation in physics. A heavy thing moving really, really fast. The ultimate weapon of the 21st century is, quite literally, a stick. So in the end, we're left with a choice. The laws of physics don't care if a tungsten rod is aimed at a military bunker or a barren moon that we want to explore. The technology is the same. It gives us the power to shatter our world or to build new ones. So the final question really is, which story are we going to write in the sky? What will we do now that we can finally afford to seize the ultimate high ground?